and today we're going to continue using elimination to solve a system of equations. So here's our first one, and hopefully you remember from yesterday that when we have a pair of opposite coefficients, we can jump right into solving by canceling those out. So in this case, we have a pair of opposites because positive y and negative y cancel out. So we get 2x equals 12 plus 2, which is 14. Divide by 2, and x equals 7. We take that 7, plug it back into the first equation for x, so we get 7 plus y equals 12. Subtract 7 from both sides, and y equals 5, making our solution 7, 5. And then we can check to make sure that's correct by plugging it into the second one. So we have 7 minus 5 equals 2, and I think you all know that 7 minus 5 is definitely 2, so we did it correctly. Okay, jumping to number 2. Again, we're lucky here because we have 3x and negative 3x, so we can jump right into solving. So 3x minus 3x cancels out. 4y minus 2y gives me 2y equals 9 plus negative 3, so that's 9 minus 3, which is 6. Divide by 2, and y equals 3. So we solve for y now, so we're going to substitute that in and solve for x. So we've got 3x plus 4 times 3 equals 9. So 3x plus 12 equals 9. Subtract 12 from both sides. 3x equals negative 3. And divide by 3. So x equals negative 1. Now remember that we solved for x here, so we have to turn around our coordinate. Our solution is negative 1, positive 3. And again, we can check with the second equation. So if we do negative 3 times negative 1 minus 2 times 3, we should get negative 3. And negative 3 times negative 1 is positive 3, minus 2 times 3, which is 6, is definitely negative 3. So we did it correctly. Okay, so that's the easier version because we have a pair of opposites. Not always the case, if you remember back from yesterday. So in this case, we do not have a pair of opposites, but right away, I see 5 and 10. I see that 10 is positive and 5 is negative, so that makes our life easy because I can very quickly multiply the second equation by 2 and get a pair of opposites because negative 5 times 2 is going to give me negative 10. So now I bring over the equations. 10x minus 7y equals 2, and underneath that, negative 10x plus 6y equals negative 6. Adding vertically, 10 and negative 10 cancel out. Negative 7 and 6 gives me negative 1y equals 2 minus 6, which is negative 4. Divide by negative 1, and we get y equals 4. So now we plug the 4 into the top equation to solve for x. So we have 10x minus 7 times 4 should be equal to 2. So that's 10x minus 28 has to be equal to 2. We add 28 to both sides. So 10x equals 30. And last, divide by 10. So x equals 3, making our solution 3, 4. And again, we could check that with the second equation. If we do negative 5 times 3 plus 3 times 4, we should get negative 3. So that's negative 15 plus 12 should be negative 3. And it sure is. If you do 12 minus 15, you get negative 3. So we found the correct answer. All right. I hope you're understanding this and that you're feeling like you could conquer this on your own. Let's try another one together. So again, this one's set up pretty easily because I see a pair of opposites in both cases. And I could easily multiply negative 4 by 2 to get negative 8, which would cancel out my x's. So we're going to keep the top equation. And we're going to multiply the bottom equation all by 2, which gives me negative 8x plus 8y equals 16. Then add vertically, 8x and negative 8x cancel out. Negative 3 and positive 8 make positive 5y, and 16 and 4 make 20. Dividing by 5, I get y equals 4. Then we substitute that y back into the top equation to solve for x. we get 8x minus 3 times 4 equals 4. So that's 8x minus 12 should equal 4. Add 12 to both sides. 8x equals 16. Divide by 8. And x equals 2, making our solution 2, 4. Remember, it's always x, then y. Then again, I can plug that into the second equation to prove I've got it right. So negative 4 times 2 plus 4 times 4 should equal 8. So that's negative 8 plus 16 should equal 8. And it definitely does. You can think of it as doing 16 minus 8, and 16 minus 8 is 8. So we did it correctly. All right, so far these have been some pretty easy ones. You're going to try 5 and 6 on your own and then come back to the video. So for number 7, we have something even more challenging. So if you look at number 7, I do see some opposites here, but there's nothing I can multiply 5 by that's a whole number to get 4. There's nothing I can multiply 4 by that's a whole number to get 5. So instead, what I'm going to do is multiply each equation by the opposite. So I'm going to multiply this top equation by 4 and this bottom equation by 5. And that's going to give me negative 20 and positive 20 in the middle, which will cancel out. So distributing those numbers, we get 4 times 2x is 8x. 4 times 5 is that negative 20y equals 4 times 80, which is 320, because 8 times 4 is 32. Then on the bottom, 5 times 7 is 35x. 5 times 4 is plus 20y equals 5 times 65. So 5 times 5 is 25. Carry the 2. 5 times 6 is 30 plus 2 more is 32. So it's 325. Now we can add vertically. Negative 20 and 20 cancel out. 35 and 8 make 43x equals 645. Divide by 43. And no, I do not know that answer off the top of my head, so I'm going to pull out my calculator and do 645 divided by 43, giving me 15. So now I can plug in 15 to our original first equation and solve for y. So that's 2 times 15 minus 5y equals 80. So that's 30 minus 5y equals 80. Subtract 30 from both sides. And negative 5y equals 50. Divide by negative 5. And y equals negative 10. Making our solution 15, negative 10. And again, I can plug that in the second equation to make sure it's correct as well. If we do 7 times 15 plus 4 times negative 10, we should get 65. So 7 times 5 is 35, carry the 3. 7 plus 3 is 10, so it's 105. Minus 4 times 10 is 40, should equal 65. And I know 100 minus 40 is 60, so 105 minus 40 is definitely 65. So we did it correctly. So again, worst comes to worst, if you can't find a number you can multiply just one equation by to get a pair of opposites, you could multiply both equations to get a pair of opposites. That's totally fine. Okay, so with that said, you guys are now going to try number 8 on your own. Okay, then lastly, we have to talk about that whole idea of it being none or infinite solutions. And you saw a little bit of this yesterday. So in this case, one of these is none, one of these is infinite. So let's see what happens here. So in this bottom one, if I multiply this all by negative 4, I will get positive 20 and negative 20, allowing the y's to cancel out. But it's also going to do something else. Let's see what happens. So I'm going to bring down that first equation. It's 12x minus 20y equals negative 8. And then multiply the bottom one. So I get negative 12x plus 20y equals negative 8. So this cancels and this cancels, leaving me nothing on this side. Negative 8 and negative 8 make negative 16. So I get 0 equals negative 16. They are not the same, so this has no solution, which we can use the symbol 0 with a slash through it to mean none. Then over here, I don't have opposites, but if I multiply 6 by 3, I get 18. So to make it opposites, I can multiply by negative 3. So again, let's see what happens. If I bring down the first one, I get 24x plus 18y equals 36. Then I multiply the bottom one by negative 3. I get negative 24x minus 18y equals negative 36. So negative 24 and 24 cancel out. 18 and negative 18 cancel out. 36 and negative 36 cancel out. So 0 equals 0. So this means that both equations are essentially the same and I have infinite solutions. If I hadn't multiplied by negative 3 and I just multiplied by 3, I would get two identical equations, proving that there are infinite solutions. So you can see that a lot of the math that we've been doing this year all ties together. We've seen no solution and infinite solutions and one solution show up a bunch of times. So you have to know that infinite means the same, none means almost the same. Okay, they have the same rate but different y-intercepts. And one is when you can actually solve for a single solution. Okay, so you are now on your own. You're going to try today's exit tickets. Check in with me so I can make sure you're getting them all right before starting tonight's homework.